My dear student, today I am going to explain about insertion of dielectric. Insertion of a dielectric in an isolated charge capacitor Insertion of dielectric in isolated charge capacitor. For example, like this charge capacitor having charge Q and disconnected to the battery. Charge Q, other plate charge minus Q, plus Q, plate minus Q. Now the dielectric I am going to insert dielectric having dielectric constant K, When this will come contact with the plates, then because of electric field available inside the plate of capacitors, then this become polarized and able to get negative charge at this edge and positive charge this side. And negative charge and positive charge attract, and positive charge of this dielectric attract by negative charge, then able to get net force toward this, and this is what electrostatic force. And I'm going to apply external force here, F external. That's why this dielectric able to move slowly with constant speed. Now I'm going to discuss about what are the property of this will change, what about the energy of store in the capacitor, what what are the potential change or everything, electric field inside the capacitor will change or not, we'll discuss. Okay, I will make one table like this. We can compare the property of dielectric before and after insertion of dielectric. I will make like one table like this. Before insertion of dielectric, of dielectric, after insertion of dielectric, First, charge on capacitor is Q, before and after also Q. Then charge remains same because no one able to change the charge. Charge is constant because capacitor is isolated charge. Okay. Then second property I am going to check, what about the capacitance. Capacitance here become C equal to before epsilon naught A by D, and here become what? Capacitance become K epsilon naught A by D, means this is the initial capacitance, this is the final. Initial charge is Q and final charge on the plate of capacitor also Q because charge is constant. Then we can say that what? Final charge nothing but, final capacitance nothing but K times of initial. Then now I am going to explain third things, what? Potential, electric potential, initial electric potential. Potential nothing but what? Q by C. Okay, Q by C initial. And here become what? Third property of this, QV final nothing but Q by C final, capacitance of final capacitance. Final capacitance nothing but K times of C initial. Then V initial is equal to Q upon C initial, and V final nothing but 1 upon K times of V initial, means potential decreases 1 by K times. Now the fourth property of this electric field initial electric field nothing but B initial by D. V initial is nothing but Q by C. Okay, V initial by D. This is the electric field initial. And final electric field final, that is nothing but V final upon D. D the separation between the plates. Then V final nothing but 1 upon K times V initial into D. Then able to get electric field final 1 upon K times B by D. V initial by D. V initial by D nothing but electric field initial. Then final electric field 1 by K times of initial electric field. 1 by K times of initial electric field. 1 by K times of E initial. This is the final electric field. Then here electric field also will decrease. Now the fourth part completed. Now I am going to explain the fifth part of this. What about the energy stored in capacitor? Initial energy stored nothing but U half CV half Q square by C initial. Then this is the initial energy stored in the capacitor, energy stored in capacitor initial. Final able to get half Q square same. That's why this is given isolated charge capacitor, means if here Q is taken as constant. Then C final nothing but 1 K times of C initial. Then able to get what? 1 by 2 Q square by K C initial. Then U final we can write 1 upon K times U initial, means energy stored also will decrease. Now next fifth part completed. Now okay, this I already explained here what charge remains same and capacitance become K times and electric field and energy. Okay, now here writing here after, before and after. Before and after, I will make one table here. Capacitance, charge, order by able to use here. Charge before Q, after insertion of dielectric also Q. Then capacitance capacitance before C now become K times of C. Then potential is initial V now become B by K, 1 by K. Then electric field before assume E now become E by K. Then energy before U final become after before U after U by K. Then everything will decrease except capacitance. Everything decreases except capacitance. And that's all about insertion of dielectric. When dielectric inside a isolated charge capacitor, then due to this electric field, dielectric become polarized, and near the positive plate of capacitor, dielectric having negative charge, and other side of near the negative plate of this capacitor, the dielectric, this side of dielectric, this edge of the dielectric get positive charge. Then this automatically able to go down because of attraction of the charges. Then I will apply external force, that's why that this will move with a constant speed, means slowly able to move. Then now I am going to study about all the things about the changes of the potential, field and charges, and electric field and energies. Now I am going to compare before and after insertion of dielectric, what will change. Then charges remain same because charge is the fundamental quantity, and before and after there is no connection, the charge will not flow because battery is already removed from capacitor is isolated charge capacitor, it's not connected to any battery. Then capacitance is the property, capacitance is independent of the charge and potential. It depends on the shape and size and medium. Okay. Before the dielectric this, now after insertion of dielectric, then this become what? K times of initial. K is the what? Dielectric constant. K is the dielectric constant. Then potential, no, by the basic formula Q equal to V into C, then Vi we can write Q by Ci. Then this is the initial potential, that is a Q by Ci. Ci already know this much. Now V final is Q upon C final, and C final nothing but Q upon KCI. And then now I am going to put the value of this Q by Ci is as V, Q by Ci is V, Q by Ci is Vi, then able to get this. Then this, if you compare this, then able to get what? K times 1 by K times of this. Now electric field here, in his electric field formula is what? E equal to V by D, and Vi nothing but Q upon Ci. Then E final able to get this. Then now potential energy of potential energy of capacitors when before insertion of dielectric is what? Ui nothing but half Q square upon Ci. This is the energy stored in capacitor. After insertion of dielectric, capacitance going to change. that become k times of C initial. Then U final now become 1 by k times of initial. Now I'm going to summarize this part in one table like this. This before the charge on the plate is Q, after insertion of dielectric again Q. Capacitance is C, that is epsilon naught A by D, now become K times of epsilon naught. And V potential and V by K is after. E the electric field before, that is sigma upon epsilon naught, now become what? Sigma upon epsilon naught K times. Okay. Then I will make here one thing here, what? Charges remain same. Charges before and after Q before and after. Q is here also same, this will not change, Q same. Then C increases, capacitance increases and become what? K times of C. Potential B, that will decreases, B by K times, 1 by K times, this decreases. And electric field E, that become E by K, that also decreases. Then energy U stored is U, then decreases, how much ever look at U by K times. Everything decreases, this also decreases, this also decreases, this also decreases, this is the same only, and this is only one things will increase, that is this only increases, and this is the same, otherwise everything decreases, this is the same, and this will decreases, this part decreases. That's all about the insertion of dielectrics. Okay, bye.